Hi, my name is Thomas James and this is Wheelie Drive version 2. I set out to create a robot that takes wheelie bins out to the curbside for the elderly and disabled, and along the way I found many other potential users for the project. I received lots of valuable feedback from my first prototype. For example, the robot should connect to the front of the bin. Because who stores their bins like this? Most people store their bins like this. The robot would also ideally be able to take all your wheelie bin sizes out, not just the one wheelie bin. Reliability of navigation was also very important to potential users. Taking all of this into consideration, I went back to the drawing board. User feedback created some interesting design requirements for my next prototype. The robot needs to connect to the front of the bin so that it could be stored with its handle against a wall. Be small enough to leave the bin close enough to the curb for the rubbish truck to pick it up. Be able to turn on the spot so it can drive away without driving onto the road. For the robot to be able to turn on the spot and connect to the front of the bin, it must treat the wheelie bin as a trailer. Knowing this, I created multiple design iterations before I ended up with my current design. A linear actuator positioned in the center of the robot lifts the bin with a ring which surrounds the robot. Supports for the ring have been designed to ensure the ring can't tip. The ring allows for the bin to rotate around the robot as it turns, enabling for turning in a small area. The wheelie bin is connected to the ring by a small hook. The hook can be added to the wheelie bin without modifying it. The hook simply clamps a support brace to the inside of the cavity of the bin. The support brace decreases the pressure applied by the hook lifting the bin. To increase the reliability of my robot, I redesigned its navigation system. I changed from using a distance interaction system to using a system which measures distances to objects in its surroundings. The robot navigates using an ultrasonic sensor mounted on top of the robot. The robot turns to face the direction it wants to travel in, and then turns the ultrasonic sensor to take the direction it needs to take. The robot then drives until a condition is met by the ultrasonic sensor. The process is repeated multiple times until the robot reaches the curbside. However, when the robot reaches the curbside, there is often nothing for the ultrasonic sensor to take readings off. In these situations, the robot also has an RFID reader mounted on the bottom of it, enabling a RFID tag to be used as an identifiable checkpoint. Another feature that needed to be improved on in the second prototype was the means at which Wheelie Drive was set off. I've incorporated multiple methods to activate Wheelie Drive to suit different users. One option is to use Google Assistant or Alexa. Hey Google, take the bins out. Another option is to use a remote. Or you can use the mobile app to set a time to automatically activate Wheelie Drive, so you don't have to. Wheelie Drive version 2. Same problem, completely different solution.